Okay, so if you can see my screen, say yes in the chat. If you cannot, say no. All right, very good. So let's continue. So today is the fourth lesson of functions, and we'll go over homework and then composition of functions and inverses. So let's start with the homework, which is graph 2x squared minus 8x plus 4. So everybody just graph this if you haven't, and I'll give you a few moments to do that, and then we'll go over this. All right, so let's go over this one. Okay, so what you need to do first is you need to put it in vertex form. So who wants to volunteer to help me out? Let's see, who can solve this for us? How about Zebo? Zebo, would you like to help?
No.
All right, how about Kaylee?
Okay.
So how would you put this into vertex form?
First you have to factor out a 2, so it's f of x is equal to x 2 times x squared minus 4x plus 2.
Very good.
And that's equal to 2 times 4 squared minus 4x plus 4x minus plus 4 minus 2.
Right. So then?
Then we move the minus 2 out, so it's 2 x squared minus 4x plus 4 plus 4 outside the parentheses.
You mean minus 4?
Yeah.
Right. So then, this is vertex form, right? So then the vertex, what is the vertex?
2, negative 4.
Very good. And then, how about, let's try to graph it now. So the vertex is 2, -4, right? So does it open up or down?
Up, because 2 is positive.
Right. So then what we can do is then we know it's going to open up sort of like this, right? So now we can plot some points. What are some points that you think are good?
I don't know.
Right, so we can look at a couple ones here, right? Because there is to the right of it, it's 3. So we can just look at that. So when x is equal to 3, when x is equal to 3, what is y?
-2.
Yeah, -2. So then it's like this. We know it's an axis of symmetry, right? So it's the same point on the other side, and we can find another point here. When x is equal to 0, for example, then it's 4. No, it's 0, actually. Yeah, I think so. Okay. It's like no, it is 4. So here, and then you can see it's a very skinny parabola like this. All right, so that's how you graph this one. Let's just do the next one then. This one was a little bit difficult, right? This one was very difficult. Because we didn't really go over the problems of this caliber last time, but you just have to follow the same principle and you're set. So let's see how you guys did. I'm gonna give you a couple moments here, maybe 3 minutes, and then you can put your answers in the chat and we'll go over this. All right. So let's see. Okay, who can help me with this one? How about Sophia? Sophia, would you like to solve this? Sophia? Okay, no. How about Jenny? Jenny, do you know how to solve this problem? Okay, if not, then who unmuted just now? Do you want to help? Okay, if not, then I'll just walk you through this. This one was quite hard, actually. So we can just do it. So this one, you need to make a sign chart. First, you need to find where the graph is equal to 0, right? So where the graph is equal to 0, and that is at -2, 3, -1, and 1. So you need to make all of those intervals, excluding those points. So let's just do that right now. So infinity to -2, -2 to 1, -1, -1 to 1 and 1 to 3, 3 to infinity. These are all the intervals excluding the zeros. Then we can look at our sign chart here. So then we are going to have x plus 2, 3 minus x, and x plus 1. You don't have to include this because anything squared is always equal to 0. So you don't have to actually include that. So next, let us determine the signs. So when x plus 2 is greater than or equal greater than 0, x has to be greater than -2. So this is negative and this is positive. When 3 minus x is greater than 0, x is less than 3. So this is positive, 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 negative. And when x plus 1 is greater than 0, it is greater than -1. So this is negative, negative, positive, positive, positive. So you should have gotten this is negative, plus, plus, minus, plus. So you should have gotten negative infinity to -2. Right, you should have gotten negative infinity to -2, union -1 to 1, union 1 to 3. So we're excluding those points that we don't need there. Okay. So are there any questions about this? If there are no questions, let's move on to the last homework problem. Yeah, okay. So for what values of x does the expression x squared minus 25 represent a real number? So we can just start doing that. All right, so let's go over this one. We have x squared minus 25. So when does that represent a real number? And that is when it is greater than or equal to 0, because as you know, we cannot take the square root of a negative number. So we have x squared minus 25 is greater than or equal to 0. And like earlier, we have a quadratic inequality here, so we can just factor. Once we factor, remember difference of squares, we can solve for this. So when this expression is equal to 0, x is equal to -5 and 5. So our intervals are negative infinity to -5, negative and 5 to 5, 5 to infinity. So you have the two factors here, x plus 5 and x minus 5. We have x plus 5 is negative here, positive, positive, negative, negative, positive. It is positive, negative, and positive. So then we want greater than or equal to 0. So we naturally have negative infinity to -5, inclusive union 5 to infinity. So does everybody get how I get that? Right. Okay, very good. Let's begin our lesson for today on function operations and inverses. So we need to review function operations because some people did not attend basic algebra where I went over these. So we'll go very quickly over function composition and these function operations. And these function operations are really straightforward, so there really should not be any trouble with that. So we can do something. So f plus g of x, right? F minus g of x, f times g of x, f over g of x, right, are equal to f of x over g of x is equal to f of x times g of x is equal to f of x minus g of x is equal to f of x plus g of x. So it's very, very straightforward. The only restriction is this is where g of x does not equal to 0, because as you know, you cannot divide by anything 0. Okay, so let's do a practice here. If f of x is equal to x squared minus 3x plus 1, and what? And g of x is equal to f 4x plus 5, then we have what is f of over g of x, right? So all we need to do is actually just divide these. Like, it's that simple. It's that simple. You don't really need to do that much. Okay, that's how we do it. And let's see what else we have here. So I was going to go over some function composition. So we all know these function operations, right? They're pretty straightforward, no questions on that. So let's go over function composition, which some of you may not have seen before. So we can see here, function composition it's this notation, f of g of x. It's pronounced f of g of x, right? Or g of f of x. It's really important what is on the other side, right? So what is this actually? F of g of x is basically f of g of x by taking g of x, the whole function, as input to f of x, right? And then we have g of x, g of f, which is the g function taking f as an input, like this. So this is a bit more readable. And basically what you're doing is you're plugging in the g function. You're plugging in g function into f, right? So then you have, basically, you can look at it this way. So let's say y is equal to g of x, right? And g of x, let's say, is x plus 4. Then g of y is equal to, well, let's say y is equal to, let's say h of x then. It just needs to be a different function. G of y is going to be y plus 4. So whatever you plug in here is going to be substituted into this, right? So when you plug in a whole function, here, it's going to be equal to h of x plus 4. So that's basically, instead of plugging in a single number, you're plugging in a whole function. That is basically what composition is, and you'll be using composition a lot later on when we learn about inverses and such down the road. That is basically composition. So let me see. We can actually do a couple of practices on composition here. So let's see any examples we have. Let's do this one. So we have f of x is equal to 3x minus 5, and g of x is equal to x squared plus 1, right? So then we need to find f of g of x, right? So I'm going to give you guys a couple of moments to try to do this by your own. Then I'll go over it. All right, so let's try to go over this. So f of g, what we're basically doing is you're taking the g function x squared plus 1 into the f function. You're plugging x squared plus 1 into 3x minus 5. So you can do this by doing plugging in the whole function, right? F of x plus x squared plus 1 is just going to be equal to 3 of x squared plus 1 minus 5. We can simplify this, right? And then if we take f of g of f of x, then we can have this is going to be equal to g of 3x minus 5 which is equal to 3x minus 5 squared plus 1, right? So are there any questions on this? If there are no questions, then I will continue to some inverses, right? Wait, actually, I do want to go over the second example here. More on compositions. Let me go over this second example here. So we can go over 2 of these. So I'm going to do the first one for you, and then I want everybody to try to do the second one on their own. So it says h of x is equal to 3x plus 5 to the 5th, right? Okay, and how do we express as 2 simpler functions? Okay, express h of x as 2 simpler functions, right? So then, how would we do this? So first, we want to simplify, right? We need to look at these as 2 parts. What is the first part? It is 3x plus 5, right? And we're going, basically what we're doing is we're taking this function, 3x plus 5, okay? And then we're raising it to the 5th power. That's what we're doing. You kind of describe it, right? So then you can kind of see your two simpler functions, which is 3x plus 5, and then x to the 5th, right? So let's just set f of x is equal to 3x plus 5 and g of x as x to the 5th. So then when you take g of f, right, when you take g of f of x, you're going to get g of 3x plus 5, which is equal to 3x plus 5 to the 5th, which is precisely equal to h of x. So that's how you simplify it as a composite of 2 simpler functions. And I want you guys to do this second one here. So let's see. Let's say h of x is equal to x minus 2 squared minus 3 times x minus 2 plus 7, and express this as 2 simpler functions. So I want you to do that. Okay. All right, let's go over this one. So obviously we can see that this looks kind of like a quadratic, right? This looks kind of like a quadratic. It looks like x squared minus 3x plus 7, except the x's are replaced with x minus 2. So then what we can do is we can set f of x as x squared minus 3x plus 7 and g of x as x minus 2. So when we compose those two functions, f of g, we get f of x minus 2 is equal to h of x, right? Okay, so that is how we make it into simpler functions. So now let's go over the inverse. So what is an inverse, right? An inverse is, so this is f of x, and the inverse is written as f of -1 of x, right? So the inverse is the same as the original function, except range and domain are flipped, right? They're flipped, okay? So when you have something, let's say f is, the domain is in -infinity to infinity, and the range is 0 to infinity, right? Well, the inverse of that, the domain would be 0 to infinity, and the range would be -infinity to infinity, right? So the range and the domain are flipped. So how would you actually determine an inverse? So by determining an inverse, you have to know that the range and domain are switched. And since x basically represents the domain and y basically represents the range, what you can do is you can flip x and y and then solve for y. So let's just try that with y is equal to 3x minus 2, right? Actually, let's not do that yet. Before we do that, I want to also tell you about one-to-one functions, because that is very important. You have to, the function has to be a one-to-one function if it has to have an inverse. Right? If it doesn't have, if it doesn't, if it isn't one-to-one, then it cannot have an inverse. So what exactly is a one-to-one function? You can determine a one-to-one function with the horizontal line test, right? So the horizontal line test. We know the vertical line test, which is testing if this function is a function or not, right? This graph, is it a function or not? Because we know that a function, there cannot be two y values assigned to one x. So it becomes even more strict with one-to-one functions, because it cannot even be multiple x values with one y. It has to be strictly one x and one y. Each x value has its own y, right? So that is a one-to-one function. An example of this would be x cubed, because each x, no matter what x you have, it's going to be only corresponding to one y. However, if you have something like x squared, it does not pass the horizontal line test, right? Because the horizontal line can only pass through the graph once, and yet here it passes through twice. And that cannot happen since this parabola, one y values has two x values corresponding to it, but a one-to-one function should not have. So in this case, a parabola would not have an inverse, and it is not one-to-one. So make sure it is one-to-one first, right? So let's now go over some examples. So remember what I said about switching the range in the domain, right? So here are the steps of finding the inverse. The first step is, of course, verify if one-to-one. Number two, write in terms of y. Actually, we can skip this. It's very intuitive. Next is switch domain and range. Which is x and y. So let's make this 2 and 3. Okay, and then you solve for y. So let's give an example. Let's say y is equal to 3x minus 2. So what happens to the inverse? Well, the inverse, the domain in the range is flipped, right? The domain in the range is flipped. So then what you have is x is equal to 3y minus 2 because we switch the x and the y because we're switching the domain in the range. And then remember, we have to solve for y to get the new equation. Y is going to be equal to so x plus 2 is equal to 3y, and we get y is equal to x over 3 plus 2 over 3. Right, so this is the new equation. This is f negative 1 of x. Right, that is the new inverse. Okay, next, let's see what we have here. Let's solve for f of x is equal to square root of x plus 2. Square root of x plus 2, we have first, of course, we have to switch the x and the y. So we get x is equal to square root of y plus 2. Then we have x squared is equal to y plus 2, and y is equal to x squared minus 2. We'll talk more about this parabola later and why the nuances and the complexities with that. Some subtle points. Okay. So let's do a couple more of these, and then actually let's just move on to the definition of inverses. So if f of negative 1 exists, we get these laws here. F of f to the negative 1, x is equal to x for all well, this is in the domain of f to the negative 1 to f negative 1 of f of x is also equal to x, but only in the domain of f, right? So we also have a couple more identities pretty similar to this. We have if f or g are one-to-one functions, and f of g of x is equal to x, and g of f of x is equal to x, then f and g are inverses, which is basically this. So that is the definition we have here. Now let's move on to this these graphs. So The thing is about inverses, they are reflections of each other, not over the x-axis or even the y-axis, but over the line y is equal to x. And that kind of makes sense, right? Because we're switching the range and the domain. So it should be reflected over the line x is equal to y. If you have f of x is equal to x plus 2 square root and f of negative 1 of x is equal to x squared minus 2. And we can graph these, we get something like this, right? Well, does it look reflected over the line? No, it doesn't, because this parabola looks off, right? This parabola, it looks off. So instead, what we need to do is we need to set this restriction. X has to be greater than or equal to 0. Right? It has to be greater than or equal to 0 because x squared minus 2 is not a one-to-one function. So once we set that restriction, it is one-to-one. Then we have this. And it does look reflected over the line y is equal to x. So remember, all inverse graphs are reflected over y is equal to x. All right. So now let's go on to our last one. So this one, not very related to what we're doing right now. This one is not related to inverses or even composition. We just didn't go over this until this last lesson. So I wanted to go over this because it is a word problem involving the functions. So this one, you need to write a piecewise function. I know everybody took notes on that. So make sure you go back to your notes and look up what a piecewise function is, and we can solve this problem. And then we'll end class after we solve this problem. So I'll give you maybe 5 minutes to read this problem and solve it. Then I'll go over it. All right, so let's go over this one. A high volume website, right, pays salespeople to solicit advertisements for placement on their site. The sales staff each gets $200 per week and salary a commission of 4% on all sales over $3,000 for the week. And in addition, if the weekly sales are 8,000 or more, the salesperson gets a $100 bonus. And find the piecewise definition for weekly earnings in terms of weekly sales. Find weekly earnings for sales of 5750 and 9200. So we're going to find E of X, which is what? It is the earnings in terms of X, which is how much you sell. We have to write a piecewise, right? So if you get between 0 and 3,000, right? You're not gonna get much, right? You're just gonna get a measly $200 per week. That's the very lowest you can go, right? Just $200 per week. Now, what about if you get over 3,000, but it's still under like 8,000, right? And you get a 4% commission. So what is 4%? It's 0.04, right? But what is it says over 3,000, right? So instead, we're not just taking 0.04 of X, we're taking X minus 3,000, which is equal to 0.04 minus, what is that? It is 120. But we're also adding the 200, that is the base salary, which is 0.04 plus 80 now. Now, what about if you get over 8,000, right? Then you get this plus 100, right? So 0.04x plus 180. That is the piecewise function. So now we can try to graph it here. You can see it starts at 200 here. And it just, after it hits a certain level at 3,000, it goes up, right? And at 8,000, it jumps because there's a $100 bonus here. That is graph. Now, what about the question here? 5750. All you need to do is you need to categorize these three categories. Well, 5750 is the middle category. It's greater than 3,000, but less than 8,000. So what we're going to do is you're going to plug that in. 0.04 times 5750 plus 80 is going to be equal to $310. $310, not bad, right? What about 9,200 in sales? Well, that's over 8,000, right? So we're going to add $100 bonus to that. So that's 548. Very good. So are there any questions about this? If there are no questions, then that's it for today. I'll see you guys next week.